Hi, Assalamualaikum warahmatullahi wabarakatuh. So we are from group 5 from EC 1104A. So in this group here, Abdul Hanan bin Mahadi, Muhammad Afif bin Mohbekri, Muhammad Haniff Fitri bin Nozaizeli, and last one is Amir Fadhlin bin Ahmad Khairuddin. So for today we are going to present to you about sustainable materials for the subject ECS 246 Civil Engineering Materials. So we present to you the sustainable materials. Okay, so here the table of contents for this slide presentation. So here basically we are going to introduce to you the wood ash and the palm oil ash as a replacement for the cement. So the table of contents for wood ash here we got for you introduction, methodology, results and discussion, and then conclusion. Also with the same content for the palm oil ash, which is introduction, methodology, results and discussion, and the last one is conclusion. After that we are going to recommend to you the best sustainable material for this slide presentation, and then here there are reference for the last one. So here we are.
Hello and Assalamualaikum. My name is Mohamad Afif and I will be presenting the introduction for this assignment. Okay, sustainable construction is the practice of creating a healthy environment that's based on ecological principles. Sustainable construction focuses on 6 principles that are conserve, reuse, recycle or renew, protect nature, create non-toxic and high quality. Okay. Besides, sustainability in construction is all about following suitable practices in terms of choosing materials, their sources, and construction methodologies, as well as design philosophy. So, to be able to improve performance, decrease the environmental burden of the project, minimize waste, and be ecological friendlier, taking into consideration environmental, socio-economic, and cultural values.
So for the first article, which is the wood ash in concrete as partial replacement of cement.
Okay, moving on. I will be presenting the objective for the first article, that is wood ash in concrete as partial replacement of cement. Okay, for the objective, this study shows the behavior of wood ash partially replace cement in concrete by weight. The achievement of binding properties by replacing concrete with wood ash or waste. After that, we want to reduce the risk of food waste and to develop safe and effective disposal methods. After that, we need to know the appropriate way to reduce concrete costs by replacing cement and intermediates with wood waste. Okay, next for the methodology, we have 3, where there is mixed ratio, curing, and mixture preparation. For the mixed ratio, the targeted characteristic strength of concrete mix M25 were designed to conferring high standard for a resultant value of 31.40 Newton per millimeter square over 28 days. Okay, next we have curing. All cubes casted after 24 hours and were then cured for 7 and 28 days for individual analysis. Next, we have mixture preparation. The methodology is control mixture with water cement ratio and was prepared. Blend. After that, blend was checked for workability and slump contest was performed to affirm the outcomes. Next, we control the sample cast for 7 days and 28 days for the test. After that, the concrete mixture was prepared in different amounts of wood ash, that is 10%, 15%, 20%, and 25% by weight, replacing cement for the same water-cement ratio. Next, additives were used to maintain concrete collapse. After that, the cube specimen remained in cache for 7 days and 28 days for the results. The results were analyzed by casting 3 cubes for every single proportion of wood ashes, that is wood ashes 1 and wood ashes 2 blended concrete. The entire process was done at room temperature.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Hanan bin Mahadi. So I am going to continue the presentation for results and discussion of this wood ash. So to test the wood ash as a replacement, a partial replacement for the cement. So we are going to do the slump assessment to test the workability of the concrete. So in the experiment, we detected the slump was shear in the replaced wood ash concrete change when compared with control mix due to the roughness of mixture because of the lack of binding material like cement in the mixture, as the proportion of wood ash in the two types of wood ash with cement increase. So at the right here we have the results and discussions. So the next is the compressive strength of the concrete. So a digital compression tester was used to test the compressive strength of the concrete cube after it has been cured for 7 and 28 days. So the outcomes of the two wood ashes, which is WA1 and WA2, replace concrete cube specimens with varied ratios of wood ashes in the concrete mixtures are represented in terms of compressive strength of Newton per millimeter square. So at the left is the compressive strength results for the wood ash 1 and the wood ash 2. So for the conclusion, according to the articles, wood ash has a poor success rate as a partial cement replacement, and different type of wood ash compositions may have an impact on concrete qualities. This means that not all types of wood ash are suitable for use as a concrete replacement. As a result, inspecting wood ash before using it in a concrete mix is crucial.
For the first one, we have palm oil ash research. The objective of this research is to minimize the exploitation of natural materials and its environmental effect. It is also to focus on the usage of oil ash palm in a concrete mixing for building material. For the experiment method, we have ultrasonic pulse velocity, which the concrete has been measured by using the velocity of ultrasonic pulse to ensure the quality of the concrete. The research was conducted based on ASTM C59709 standard at the age of 3, 7 and 28 days on 100 mm cubes. Next, we have mechanical properties. According to BSEN 123903, the research was conducted on 100 mm cube specimen at age of 3, 7 and 28 days. Then, as per ASTM C49611, by using 200 x 100 mm, the 28 days flinting tensile strength was conducted. Last one, we have transport property. The transport property are a non-destructive test of concrete. With that, we include absorption rate, porosity and sorptivity tests. Okay, now we're gonna see the result and finding. For the left side, we have UPV and the right side, we have compressive strength.
So, my name is Mohamad Fitri bin Nozaizeli. I will tell about discussion palm oil full ash, OFA. OFA is byproduct by biomass power plant in which palm oil residues such as fiber, shell, and property fluid brush are burned to generate electricity. However, there is another idea to use the ash as replacement for cement because the cement comes from limestone so can gone. So we need another alternative to make concrete. So the solution of the problem is to need alternative cement like POFA. POFA is better in compression strength than normal concrete. So this will make POFA become good to use in construction and good building. POFA erected concrete is highly sensitive to current environment. So this is not suitable to use a lot in one place. The lower content of calcium oxide in POFA, which is crucial for strength development, tends to limit the use of this as particle cement replacement material. Initial lower content of calcium oxide reduce the yearly stress development due to the lower amount COMPRESSIVE gel produced through hydration process. Then the smaller amount of lime produced from hydration process is also not sufficient for complete pozzolanic reaction to take place, which also lead to the formation of lower amount of secondary COMPRESSIVE gel. This provides explanation as for why not all POFA replacement level could produce erected concrete having higher strength than control specimen. However, to settle this problem is combine POFA with OPC, so the winners will be had with OPC.
Next, we have the contribution. First, we have reduced pollution. The uses of pile-on ash contribute to decrease of emission by greenhouse. Next, we have improved quality of cement. From previous research, it is said that all palm ash can improve up to 30% of concrete compressive strength. Last one, we have reduced the use of natural material. The usage of all palm ash provide a new sustainable material that can be used to create a concrete.
Conclusion of oil palm ash is, according to my research, POFA problem can be helped with OPC, and POFA is still good alternative to use another than OPC because it only need to use little of OPC to make the concrete using POFA material become strong. In the future, we can make OPC and POFA already combined in good ratio, so the problem for using only one material can be avoided from happening.
Hello, welcome back. So here we almost to the end of the presentation. So I am going to recommend you the best sustainable material. So both POFA and wood ash has their own pros and cons, depend on the objective of the construction. However, after analyzing both research works, palm oil fuel ash was found to be ideal in the development of non-structural concrete such as sidewalls, borders, and filling. However, in order to maintain the strength of concrete, it is recommended that only 20% replacement with POFA. So, in the nutshell, palm oil fuel ash or POFA is more ideal compared to wood ash for replacement of the cement. So that's all from us from group 5 of EC 1104A. So that's all from us, and thank you especially to Dr. Marzuki for teaching us for this subject and for this assignment of sustainable materials. So that's all from us. Thank you.